Hello, everyone. I will be talking about one market liquidity today. I am talking as a community member, but also as part of the development team at TibetSwap. To start off, we have to take a little look at the history of TibetSwap. So I would guess the first important moment was when Yakuhito was created. This is back when Chia first started in 2021, and there was a hackathon. And my product was this cross-chain offers product that allowed you to basically trade Chia for ETH or Chia for a fork of Chia. It's basically cross-chain offers. And although the product didn't end up working quite well because both parties needed to be online at the same time, this led directly to TibetSwap in 2023. So a little context about that period. The documentation for Chia Lisp was a set of operators you could use in Chia Lisp programs, but that was it. If you wanted to learn more about, say, singletons, you had to read the singleton code, understand it, and then try to interact with it until stuff worked. If you wanted to know more about the coin set model, you had to look at the full node source code, understand what's a coin span, what's a span bundle, and so on. So at the moment where TibetSwap was launched, there were about 2 other teams working on AMMs. One of them had an 18 months head start, but probably the majority of the community didn't think that AMMs were possible at all because it was taking all this time, and we kept hearing how complex Chia is. And indeed, in order to launch an AMM, you have to use the CAD primitive, you had to use the singleton primitive, the offers, and you had to develop custom puzzles. So you had to take all that was available at the time, put it together somehow, and make an AMM work. Thankfully, after you do that, it's pretty simple to launch to mainnet, and that's why today TibetSwap is the leading AMM to code the Chia S1. We have over 120,000 transactions that were settled, about 500,000 in liquidity, according to the Chia price yesterday, and over 100,000 XCH traded in total. Now, the first piece of alpha for this talk is that there's actually been this thing. It's an intermediary version of TibetSwap that has been in the works for quite some months. Unfortunately, though, it wasn't released for reasons I'll discuss a bit later in this talk. What it did do is it led to these things we call the action layer and slots. So these are primitives that make creating the apps easier, and that includes future AMMs, or it includes other apps. Right now, if we take a look at the things that action layers and slots power, we have XCH handles, a decentralized naming service for Chia. We have catalog, a shared cat registry. We have the upcoming action chip. We have a project I'm not allowed to talk about. We have the DIG reverse distributor, which you'll hear more about in Michael Taylor's talk. And lastly, we have an upcoming version of TibetSwap, which I hope to describe more in the upcoming slides. Now, I wanted to address the dates here. It's very hard to time events because these things happen at the same time. So these are the months where most commits were made for a thing. So for example, the last version of TibetSwap, most commits will start being made in May, and it will finish probably in a few months. Of course, if you look at the actual timeline, there's a lot of stuff going on. So for example, between Yakuhito and TibetSwap, to make it all possible, some projects that kind of had a secondary effect were, for example, GreenWeb. This was a Chia Wallet SDK precursor coded entirely in TypeScript. And that's how you get the sense or the knowledge of how CoinSet works before you can code something like TibetSwap. There is, of course, Far Academy, which is a Chia RPC service. This has been powering TibetSwap for a while. It also powered the bridge when it launched, but we recently switched out to a better solution. But to make an RPC service that's scalable and can power an AMM on Chia, that took a few months to figure out, of course. We also have other apps, such as Warp.Green. This will influence TibetSwap indirectly because it brings liquidity in the ecosystem. People need to swap that USDC to XCH or whatever they want. So this is what I mean by secondary effects. Now, for the remainder of the talk, I want to concentrate on TibetSwap and the question of how can you build the best AMM there is to power one market liquidity? The first talking point is oracles. So I would like to ask you, why does an AMM always seem to have the right price of assets? And the answer is that because it's a decentralized app, anyone can do trades both ways. So if the price is wrong, as we perceive it, it means that one of the assets is at a premium. So pretty much any arbitrage bot can buy the asset somewhere else on the market at a lower rate, then sell it to the TibetSwap at a premium and pocket the profit. And that's how, because selling the assets leads to a price decrease, that's how you kind of get at the ideal price for the asset. So people on our chains have been turning pools into decentralized oracles. Turns out that if you average the price over a time period, say 15 minutes, you get a pretty accurate image of what the price of an asset is, and you only depend on the AMM pool. And the AMM pool is great because it's decentralized, it's permissionless, it's very hard to trick the oracle that there's another price to manipulate the oracle, because whenever you do that, you risk someone else arbitraging your price manipulation, and they make a profit, you lose money. So Tibet 2.5, one of the main reasons is that it died is because on Ethereum, it's pretty easy to get access to the time to do that mean of prices. Well, turns out on Chia it's not that easy. You have access to the last block's timestamp, and that's it. It's kind of a feature of the CoinStyle model, but this time it led to the kind of annoying property that every time you did a transaction with TibetSwap, after one transaction block, that mempool item would become invalid, so the site or your wallet would need to broadcast a new transaction, which was kind of a deal breaker in terms of user experience. And thankfully, that's something that we now know how to solve. The second feature of TibetSwap that made it great, but also showed that it was version 2.5, not really version 3, were liquidity farms. So the way it works is that the protocol sometimes wants to incentivize more liquidity into a pair. So for example, let's say that TibetSwap governance wants to incentivize XCH to warp USDC, and for that, they start a liquidity farm. Now, liquidity providers will add liquidity to the pool, so they add assets, and they get liquidity tokens in return. Now, they can put those liquidity tokens in a liquidity farm, and they also earn the protocol tokens. So, for example, Yak tokens. Whenever they want to get out, they withdraw their liquidity tokens, so they stop getting the protocol tokens, and then they can withdraw their liquidity as well. The problem with this is, how do you decide what to incentivize? Because it's a very big load to put on governance. I could make a proposal saying, OK, let's allocate 20% of the emissions or rewards for the next week to pool A. Let's allocate the remaining 80% to pool B. And then someone will come and say, oh, let's do 30-70% instead. And then someone will bring on an argument to do it 31-69%. And maybe after a month, when you finally have some consensus, you're very far from the actual optimal percentages, because people, well, they like to discuss, and you need to reach a compromise to get a proposal passed. So I've been thinking about a solution for quite some time about how to allocate rewards. And it turns out that this has been already tried on other blockchains. And on Phantom, which is now Sonic, one of the few places where they still do DeFi experimentation, they invented this very great model where you offload the responsibility to choose where to allocate rewards to another party that you just created. So the AMM now has kind of three stakeholders. You have traders, which just want to get from asset A to asset B. You have liquidity providers, which provide assets A and B for trades to happen. But you also have these voters that have a stake in the protocol and a stake in making the right bets. So what I mean by that, let's walk through an example for airdrop.finance. Now, to become a voter, you need to have some error tokens, some governance tokens that you lock for a long time. That's 1 year or 4 years. And that way, you are interested in seeing the value of the tokens going up. And you think that, OK, maybe I think that a lot of USDC are going to come on Chia. So I think that's a very promising pair to incentivize. And in return for making that bet, you'll earn future trading fees for XCH USDC. So now you are kind of redirecting all emissions that you can control to the pool of XCH and USDC. Now, liquidity providers will see that kind of set predictable rewards. So they know, OK, starting next week, this voter may point it to this pool. So this pool is going to get rewards. And I know exactly how many rewards. They can decide to add liquidity. And then traders end up getting a better price. Now, voters, in return for choosing the pair, will get trading fees in return. So in this scheme, everyone kind of wins something and then gives something away. Traders, they receive better liquidity, but they pay trading fees. Voters, they lock governance tokens up. They get trading fees, which are correlated with the quality of the choice they make. Because if they vote for something that won't have volume, they will get no fees. But they give away token emissions, so new tokens created to incentivize liquidity providers. Liquidity providers get these new tokens, but they offer liquidity in return. Now, I will skip this part for the purpose of time and to minimize confusions. But it turns out you can slightly modify this model to extract some fees in some condition when the protocol has an advantage. So if you are the only AMM, or if you are integrated in a wallet, that kind of competitive advantage actually translates to you being able to redirect some of the trading fees to the DAO. So now the voters are handling kind of the short-term decisions of where do I put more liquidity. And the DAO can concentrate on longer-term stuff, such as which projects do we fund to increase trading in the future, or should we get a new version, a new audit, and so on. Now, the last point about why the current version of TibetSwap isn't very optimal is because the thing it was modeled after, which is Uniswap v2, is not very efficient. It's not very capital efficient. So this is a message sent by one of the Uniswap developers to the actual creator of Uniswap v3, which is the latest version. And he explained this. If you assume that the Ethereum price will never be less than $10, you can provide 25% less liquidity and still have the same slippage. So in other words, if you assume the Ethereum price never dips below $10, you can get away with providing 25% less liquidity for kind of the same profit. I tried to do some of these calculations myself, and this is just a public formula that you can just plug in. So to repeat what he said, if you assume the Ethereum price is between $10 and $5,000, you need 25% less capital to have the same effect in a concentrated pool as you have in a Uniswap v2 pool. Or if you provide the same amount of capital, you have a little bit more risk, but you can earn 25% more reward. Now, if you do a similar calculation for Chia, and this is just an example, if you narrow down the price range to 5 to 50, you need less than half the capital to have the same effect. Or if you provide the same amount of capital, you'll get more than twice the rewards. Where this comes in handy and is really good is when you have two assets that you can kind of predict the price ratio to. So it's very hard to predict the price of XCH in the next week. You have to go with a wide range. But as you narrow it down more and more, you become more efficient. And an example that could work right now, because of the bridge, you can pair USDC and USDC.B. And if you assume they'll always stay 1-to-1, then you could get away with providing 2,000 times less capital for the same effect. So to put that into numbers, if you have a Uniswap v2 pool with $1 million in liquidity, That's the same as a concentrated pool with $500 in liquidity that made this informed bet that the price ratio isn't really going to move past 1. This is, in my opinion, the best argument for token-token pools. You can get away usually with trading from one cat to XCH to the next cat. So you are kind of having intermediaries. You are using XCH as an intermediary for your trades. You can do that with liquidity positions as well, and you end up having the same effects. But here, here for USDC and USDC.B, you can make the same assumptions. You can say, okay, USDC and XCH will have this ratio, and XCH to USDC.B will have this ratio. You can make an informed bet that instead of token A to token B being 1, token A to XCH to token B will be just as narrow. So this is the best argument for cat-cat pairs. And this has a star because everyone thinks they need cat-cat pairs, but they need something a bit more advanced. An example is that you'd like to still have cat-XCH pairs. But Permuto is coming up with these DCs that are not really cats because they have a revocation layer. So if you do cat-cat pairs, then you won't be able to trade Permuto ACs and DCs. So what you actually need is pairs that support 2 assets. And these assets can be XCH, they can be normal cats, or they can be special cats, which are DCs or ACs, or hopefully the governance can add more kinds of cats as the protocol evolves. And this is through a pattern called the cat maker that we are actually already testing for XCH handles. So to kind of give you a picture, I would like you to concentrate on the left. And that's a concentrated liquidity AMM. So there, each rectangle is a position. You have wide rectangles. So these are people that put bets on kind of wide liquidity ranges. So that's XCH being between 5 and 50. They spread their bets through a lot of prices, a lot of ticks, and that's why their liquidity is wide. Now you have other people that make better informed bets or narrow bets. This is the USDC.B example where the ratio is kind of 1-to-1. And because you make a very concentrated position, you can provide more liquidity for that exact price. The funny thing is that we constructed this going from a general Uniswap v2 AMM, and we arrived at the conclusion that this is capital and gas efficient for most assets. But if you go the other way, if you take a centralized limit order book and you optimize it for liquidity providers to use the least amount of transactions and gas, you get a figure that looks kind of similar. So you want anyone to be able to specify ranges. Usually they just want to provide liquidity for 1 tick. But their needs as a liquidity provider is actually for the order to kind of recreate itself without them having to interact with it. What I mean by that is that if a liquidity provider makes an offer for 5 XCH for 10 USDC, and that's accepted, you then want the reverse offer to be created. So the liquidity provider would want to create 10 USDC for 5 XCH. So these are basically so going from 2 different directions, you arrive at this construct that's concentrated liquidity AMMs that is essentially the same properties. Uniswap v3 is very efficient if you want to be a liquidity provider. Now, if there is something I want you to get out of this talk, is not our vision at TibetSwap of what the best AMM looks like, but it's rather how to think about liquidity. There has been this kind of war in the community, offers are better, but AMMs are better, and so on. Well, I'm here to tell you that they are actually 2 sides of the same coin, and they have different properties that help you. So if you get something out of this talk, I want you to picture a 2-sided coin. On one side, you have permanent liquidity. So that's the kind that liquidity providers deposit. They want to put their capital to work, so they are willing to go both directions. They just want something efficient that will earn them fees. On the other side of the coin, you have ephemeral liquidity. That's people just wanting to do one transaction. They want to go from asset A to asset B. And offers are the best of this because they only require one chain transaction. They're kind of the optimal solution for one-off trades. But if you want to go into liquidity provisioning, you go into permanent liquidity, which is powered by these AMMs that are efficient that I described. One other thing, when you picture a coin, the two sides are connected. And this is obviously also true for offers and AMMs. You can try to make a bot that emulates an AMM by kind of regenerating offers and broadcasting them continuously. It just has more drawbacks than advantages for using offers. So yes, you can go from one side on the other, but optimally, you are on your side that best fits your requirements. Second, as a trader, you see the whole coin. A trader wants the best possible price for an exchange. So they'll go part ephemeral liquidity, part permanent liquidity. They go from token A to token B, and how much they go into each side and how much they leverage it depends on the price cost they get from each side. With that, I would like to thank you. You have our Twitter in the bottom of the screen. If you want to write me a message with questions, probably because you are not attending today, you have my private Twitter as well. Thank you.